Have any? Go for it.
Um, yeah, just the really the only question I had today. So I went through like the instructions that you had written for the face-to-face redo stuff,
Right.
and and sort of like to sum it up, what I've been doing is just like cropping the question, pasting on a Word document, then pasting my handwritten solution, and then just repeat kind of all the way down.
That's exactly what, yeah, exactly
And
what it is.
okay, boxing off the answer. Yeah.
Yep, good job. As long as you, the big part that I want to see so I can easily assess what you're doing and grade you appropriately is I want to make sure you have the equations that you use written down and that when you first use each one, you put the units in so I know you put the right numbers and knew what the units were and that sort of stuff. If I see that next to like a word solution or some other
Okay.
technique is fine, but really I'm just looking for you showing me the equations you're using, putting the numbers in with numbers at least initially, and then solving every stuff, and then solving everything, and then boxing or circling the answers. Then you're golden.
Yeah. Pretty much just showing you that we understand what
hmm
we did.
If you can write sentences
Okay.
and that stuff, that's good for you, and it helps me, and it's an excellent habit to get into. But I've stopped shy of telling you you had to, but the more you do, the better off it'll be for you personally, with future
Yeah.
classes as well as just learning the material.
Okay. Yeah, that's what I've been doing, just kind of writing it out or like including the equations and stuff. So, okay. Yep. Just wanted to make sure that was pretty much it. Oh, actually, the next thing was now the test times that you had sent out for the final exam, could
hmm
those, is that with you personally or do they need to be taken to the testing center?
No, that's with me personally, but you're also welcome to use the testing center since you're one of my internet students. That's always an option for you guys.
Okay.
So you
Sounds
can
good.
still
And just
do the
whenever it's okay,
yeah,
just whenever it's posted, just hit up the testing center.
yeah, or you can make an appointment even this week if you have a particular day. I will have everything posted by Monday morning, and then people can take it. For your class, you're supposed to be able to take it. I'm allowing up to 1 day late. So whatever day your lab meets on that, the day after that is the day you're supposed to have it done by, in principle. So does your lab meet on a Tuesday or Wednesday or Thursday or?
So yeah, our lab meets on a Thursday actually.
On a Wednesday? Okay, yeah, I talked to
Yeah.
someone. I didn't realize I'd forgotten that. So that means you can, in principle, take it as late as Thursday, as Friday, but you definitely have to use the testing center for that.
Yeah. Okay. But yeah, I'm gonna try and do it obviously earlier and just so it's easier for you to grade and stuff. So or get all the grades and stuff together.
Yeah, I was mentioning. I told this to all the students in my classes. Hopefully, I suspect you heard me when I said it, but basically, there's a small chance that, sometimes I've done this in the past, so there's a small chance that I take questions from the old tests and pretty much only those. I guarantee 80% of the points will come from the old tests. That's my standing rule anyways. But I have in the past just taken questions straight from an old test. Sometimes
Okay.
change the numbers and not made a multiple choice, just make them regular test questions that you have to answer and work out. So that could happen. That's why I've been trying to stress you guys to make sure y'all go back and redo those old tests. So
For like the redos and stuff like that specific
exactly, just so
also.
you can get a chance to learn it. You're in
Yeah.
241, right?
Yeah, I am.
Okay.
The yeah, Monday, Wednesday night
I
class.
found one problem had an error in it in the grading of the face-to-face test for my 242 class. So I just want to make sure.
Oh, gotcha.
It might have been in my 202 class and my 242, but I think it's just my. Actually, I think it's just my 202 class.
Okay, cool. Sounds good. Well, that's all I had.
No problem.
Thanks.
Thanks, Alec. You're welcome to
Yeah.
stick around. Anybody else have any
Okay.
questions? I saw
Yes,
Eric.
I do, sir.
Hey, Hussam, what's going on, bud?
Good. Pretty good yourself.
Not too bad. Just sitting here getting ready to help my students if I can.
I have only three questions, fast questions, please. The first question is about the three tests that we did already.
hmm
Uh, Speaking of which, um, I didn't understand what is the assignment requirements to do them again through a paper, then submit them back. Do you
Right.
need the whole, basically, what we like the solution fully on the paper, then send a picture of it?
Yes, that's so I assume you did read the assignment thing because it sounded
Yes,
like you were doing that. And I know, English isn't your first language, even though your English is really nice.
I
So
appreciate it for that.
don't feel bad about that. But yeah, you're supposed to take a Word document, click up at the top where you have the margins and click it on, put on narrow margins, which makes them down to a half an inch so you have more room. And then you just
Mhm,
take and post your photograph of your question one and then your
mhm.
answers for question one. And then below that, once you finish working a solution that you think is neat enough and all that stuff, you can take a photograph of that solution and then paste it right under the answers, and then do the same thing for question two.
Gotcha, sir. Okay, that's great. The second question is about the homework. I watched the video again, and you said 11 and 13 and 15 are extra credit. But
11, the homework will be yes, and 13 and 15, or excuse me, not 15. Yeah, 13, 14, 15, 16 as
11,
well.
13. Yeah. So 11 and above are extra. What about if I didn't complete from 9 or 10 to 11?
Those are all going to count as zeros, but remember, I was warning you all this semester that, hey, just try to get a 70, 75 or better on your homework system because getting focusing on making sure you get 100 sometimes makes you do find a way to solve a problem incorrectly. So, in an effort to avoid that, because there are some mistakes in it, I suggested that you basically just shoot for a 75 or higher, and then at the end of the semester, I'd tell you a good story. Well, here's the good story. I've decided basically if anybody's grade, homework grade, is bringing their grade down, then I throw the homework grade out, and basically you'll just be graded uh, proportionately like the syllabus said, but without the assistance of the homework grade. So the homework grade won't count against you or for you in that case, because obviously it would only count against you if your grade's low. So that's what I'm doing regarding that. That being said, still, by Monday, I'll have it inserted such that all the extra credits will be deducted so that it won't be parts taken off your homework grade. And the way I do that is basically I count the number of homework assignments that you were supposed to do, and then I count how many we have to do, and then I take the subtraction of those two numbers and basically make the all the other ones dropped as the lowest grade. So, for instance, if I had 15 total and there was only 10 I was grading you on, then I would set it up to drop the five lowest grades because 15 minus 10 is 5. So that's the way it'll show in the grade book. Like definitely by Monday, early morning Monday, it's actually going to be done Sunday night. But definitely by that time, your grades will be showing with that, and it's not going to change until I do my grading thing. Far as the way where I said I'm not going to grade your homework if it's harming your grade, that won't ever show until the very end when I put your final grade up. But you can imagine that if your grade is your homework average is lower than your test averages, then you're probably being harmed by your homework grade, and your grade will only go up from there.
I appreciate you for that. That is what I need for today. I think, another two questions about the practice test. I
Okay,
don't have the practice test on me right now, so I'm gonna come to tomorrow's meeting, and hopefully
no
we can figure
problem.
it out.
We got one student. Sydney had just typed in some stuff about a question anyway, so I've got that one I can work on. Uh, I'll go ahead. Let me address this one right quick. It says, ah, it was not that question, but I am looking into that one, Sydney. After she said that it's two non-large non-conducting plates, surface area carry equal but opposite charges. Was the energy density of the gotcha. That are you saying that was the one that you were asking me about, Sydney? Gotcha. Okay, that's cool. Yeah, I will double check that again, uh, because I assume you worked it and you got an answer that was different than the one in the book. So when they're yeah, gotcha. And I'm assuming you're saying 75 microcoulombs. Okay, that's cool. I will check that. I will check that right after class again. I think I remembered when I first saw your email. Of course, I might be thinking of one some time ago that someone else sent. Me in my memory. But anyways, I'll double check that. Student asked one question so far. The vertical component of the velocity in the projectile remains constant during this entire trajectory of the projectile. True or false? That's false. The horizontal component does stay constant during the entire free fall portion of the projectile motion, not the vertical component. It said it was incorrect. For me to see what's wrong with that, there's probably a better question. For instance, a better answer because that's why I tell you guys when you want to ask me a question that darn it, that if you want to ask me a question about a problem online, you send me a picture of the answer choices as well, so that I can see what the best answer is. If you have those other choices, I'll tell you what's probably it. There actually is, like I discovered the other day, there is a chance that it has a erroneous answer in it because it's really easy for me to click in a question and then hit the roller ball and it'll like change the answer and I don't even know it happened. So that might be what happened. Hold on a second. My wife was just trying to call. Okay, got that taken care of. So yes, I will definitely check that out, Sydney. And did you find the other answer? Oh, there's the other answers that you sent me, Sydney. Brittany, if you do see those, or Honesty, sorry. If you do have those other answers, let me know. I can answer that in real time, or I can just get back to you afterwards. I'm looking at Sydney's. These are the possible answers. Gotcha. And the question was, okay, so let me just explain to you real quickly how to do this one, Sydney. It says two large non-conducting plates of surface area A equals 0.25 square meters carry equal but opposite charges. What is the energy density of the electric field between the two plates? That energy density formula is the thing that I told you was supposed to be one half uh, epsilon zero e squared. So what you have to do is figure out exactly what the electric field strength is between the plates of the capacitor. So that's usually done by taking, for instance, multiplying. Well, you know that multiplying the electric field times the distance. Excuse me. Yeah, the electric field times the distance gives you the actual voltage. So if you have the voltage, you can find the electric field by dividing the voltage by the separation of the plates. And once you have that electric field, you square it, multiply it by epsilon zero, and multiply that by zero point 0.5. That's the charge, or that's the energy per unit volume, which is what they're supposed to be asking you for there when they say the charge density or the electric field energy density. Uh, got that. You did use that formula, okay? Times 10 to the 15th joules per cubic meter. Yeah, that sounds. I don't see what other information did they give you other than the 0.25 square meters. Did they give you the charge, or did they give you the voltage, or the separation, or what? Sydney. And when I get through this one, I'll ask Hadiz next on deck, and then Brittany, and then Cage. I don't even know why I asked you that. Honestly, I'm sorry. So I used the formula. I got that Q equals 75 microcoulombs. So 75 microcoulombs was the actual charge that they said was equal but opposite on the two plates. So that gives you Q. You're still going to need V or C to get the electric field. Right now, I just don't know how you were able to get the formula for it, but I can check that. While she's working on that, Hadi, go ahead and ask me your question, bud. Actually, if you want to take a photo and text it to me or email it to me, I can get it in my emails, and I can look right at the question if you do that, Sydney. If not, we'll just wait till afterwards. Not a big deal.
Hey, could you hear me okay?
I do now, Hadi.
I got you. I wanted to ask you a question again about the angular momentum that we
Mhm.
started on in class. The one
Right.
where the person is standing on a disk that spins freely without friction, I believe,
Yeah.
holding a rotating disk. Um, Trying to find the question on Cengage, I couldn't find it again, but I have it over here in text if you would like me to read it off.
You can do that, or if you can, you could in principle paste it into the chat, but that might be a little long. But you can do that. I'll actually look for the question as well. Was this a homework question or was it one on
It
MyLab and mastering?
It was in the homework questions. It was, I believe, chapter 10. It's angular momentum, so I would assume it's chapter
Yeah,
10.
that's either
I
10
have
or
it,
11, right?
I have it in text over here.
Read me like the first four words. I think I can find it from that.
It is a person standing on a platform initially at rest that can rotate freely without friction.
Okay, a person standing on a platform. Let's try that. Uh,
It stands. I don't know if
oh,
it's standing will ruin the search.
let's see what that does. Okay, looks like I got nothing there, but trying again. And we think it's chapter 10, but obviously it could be 11. But let me double check.
Um, I'm looking at 11 right now. It could be. I've been searching the. Yeah, I think this might be 11. Um, Number 6. Okay, yeah. Yeah, you're right. It was chapter 11.
It was chapter
Um,
11? Okay, I'll go back and get that then.
Chapter 11, question number 6, or problem 11.9.
Gotcha. Oh, and one of the face-to-face tests?
No, on the Pearson,
Oh, okay,
my
gotcha.
lab mastering. Um,
That's different then. Let me get to that. We'll see. We're here. I'm gonna go here. I think I can do it here. So let's do mastering assignments. And you said it was on the chapter 11, so I'm gonna pull that up real quick and look at it. I was in my bank of questions for the homework and stuff. Oh crap, that's conceptual. It should be in the regular, not conceptual. And you said it was problem.
Problem number 6 in the assignment, but they have it written down as 11.9. Problem 11.9. I don't know which.
Oh, okay, gotcha.
Kind of confusing.
So I see 11.9. It says a person stands on a platform initially at rest that can
Yep.
rotate freely without friction. The moment of inertia of the person plus the platform is IP. The person holds a spinning bicycle wheel with its axis horizontal. The wheel has a moment of inertia I W and angular velocity omega W. Take omega W direction counterclockwise when viewed from above. So the disc that the person is standing on. No, that's the wheel. Okay, that's weird. It. Oh yeah, this is the one you asked me about in class. It looks weird. It says the moment of inertia of the person plus the platform is IP. The person holds the spinning bicycle wheel with its axis horizontal. If its axis is horizontal, I don't know how to make up the direction is counterclockwise. Mm.
I I believe they say that somewhere.
Yeah, it
Yeah.
says take omega W direction counterclockwise when viewed from above. So I guess they just mean when it's horizontal, it's still going to be counterclockwise, but then when you flip it up, it'd be counterclockwise from above. But what they're asking you for in the first part, it says what will be the angular velocity omega p of the platform if the person moves the axis of the wheel so that it points vertically upward. And
Yeah.
yeah, you got that one. I think you got that one right. It's IW over IP times omega W.
Yeah, that was just like the conservation without any vectors, without nothing.
Right. So what the part B it says what will the angular velocity omega p of the platform B, if the person moves the axis of the wheel so that it points at a 60-degree angle to the vertical. So
Yeah.
what you have to do there is take the component of it that is, since it's now at a 60-degree angle, you want to take the component of it that's vertical. And I think what you're going to find is the component of it that's vertical is given by the cosine of 60.
Yes, but I don't know how to like visualize that. Could you like draw it or like show
Yes.
like the vector breakdown, please, or something like that?
Yeah, let me first off, let me fix this and then I'll show it to you. Let's see, copy this, duplicate. Or, oh, I clicked on the wrong one. Okay, I'm going to go ahead and share my screen with you all real quick. And please hold on, everybody. I know all of you have questions, and I'm here to answer all of them. I'm just trying to go down the list, which is more or less alphabetic. Hopefully that helps. So you're now looking at this. So what we're talking about on this is if you set up the wheel so that this right here, actually that's a little too small of an angle. I want it to be 60 degrees. So this would be like our Y, our Z axis. And then this right here would be the omega of the wheel. And this angle right here would be 60 degrees. So what this is made of is a component this way and a component this way. So you need to figure out, since it's now tilted at omega 60, or excuse me, at 60 degrees, then the vertical component of the omega W vertical, is equal to cosine 60 degrees times omega W. So cosine 60, of course, is 1/2, so that just gives you omega W over 2. And then when you plug that into the formula, omega P equals uh, omega W vertical this time times I W over, in this case, it was the omega, or the, oh, I said omega WP. Sorry about that. It was supposed to be the other way around.
So, like here, why do we only care about the vertical component of the momentum or of the velocity? Wouldn't it,
Main,
wouldn't,
Right. That's a good point, but the reason why is because you actually are applying a force to the wheel axle situation, holding it so that that horizontal component of the angular momentum of the wheel is basically just being restricted from changing the rotation of the desk very much, specifically because the desk only, or the disc that it's on only rotates about an axis that's vertical. So it basically that's what's fighting it. But this should be IW, the negative, of course, over IP times omega W sub V. So this is where the 1/2 omega W comes in. So did you understand what I was talking about that with that drawing, as well as with why you don't have to uh, concern yourself with the horizontal component? Specifically, the horizontal component is going to cause like a precession or something like that, which you're just trying to figure out what's happening to the disc. It was sitting still, but now that I took this wheel and I lifted it up, it started rotating the opposite way as the wheel did. But then if I tilted it at a different angle, it's going to be at a different rate because now the vertical component isn't canceling out as much vertical component for the disk. So that's basically what's going on with that. Did that help you, Hadi?
sort of, so is it like that we only have a change in the vertical there? Because like also the linear or the angular momentum in the x direction is also changing, right? It's going to be like the sine of 60 or the sine of 60 times w. So it's we have a angular momentum in the y direction and angular momentum in the x direction here in this drawing or in this state.
Yeah, so you have at least an angular velocity component, and then of course once you multiply that times the moment of inertia, the I, then you have something that's angular momentum. But right now we're just talking about the angular velocity. So what we had was well, we basically had I omega times, or what was it called? It was called IP, wasn't it, for the bicycle wheel?
I person and I wheel, yeah. I person would, yeah, be referring to the disk.
Oh, okay, gotcha. So, yeah, I had to read it again. So the basically initially you had zero angular momentum, and then you had the angular momentum of the person plus the angular momentum of the wheel, and that had to still add up to zero. So you end up taking IP times omega p plus IW times omega W is equal to zero. That's where the negative came in, and that allows you to solve for it. Now, again, though, when you did it where it wasn't perfectly parallel, then what's going to try to happen is it's going to try to actually make the wheel, like you tilting it is like you might be trying to lay it down straight forward this way, but because of the laws of physics, when you go like this, it might make it jerk to the right or to the left. You have to work out the details of that. But that is something that your body just overcomes. That's why you don't have to worry about the horizontal component of the angular velocity.
But initially, the initial angular momentum is not zero. It has the angular momentum of the wheel, doesn't it?
Oh, yeah, yeah. Well, yeah, yeah, that's right because he didn't he was holding the wheel from the beginning, wasn't he?
Right, yeah, yeah, yeah. And the wheel was spinning.
Okay. So in that case, it started off without it zero, but it was IP times omega p well actually no, it was I
It
wheel
is
times
it
omega
is
wheel.
I wheel times times omega wheel plus zero, which would be the angular momentum of the person, equaling to the new angular momentum.
Right.
Now, the initial angular momentum would be if the wheel is vertical, would be pointing in the positive y direction or upwards, right?
Right.
So then the new angular momentum would be the omega times cosine of 60 upwards, but then we have just the horizontal component with nothing to cancel it out.
Right, but the horizontal, I mean, notice when I drew that diagram, for instance, that picture, that horizontal component is part of what the wheel the person was holding had initially. So you have to use that more or less to address the total angular momentum. So the vertical components cancel each other out so that you have zero component after he's moved the wheel, but you're still left with a horizontal component that has to be accounted for because the initial angular momentum was only sort of in the horizontal direction because the wheel was laying over, its axle was laying over sideways and it was spinning like that, something like
But,
that.
but wouldn't that also mean that the person might have a change in that the platform he's standing on would also tilt in some kind of way to
No, I
cancel
mean,
out?
in principle, it would try to, but that's sort of the whole point is they're saying you're on a platform and that platform's not necessarily free to change axes or anything.
So a force would be applied, it's just not great enough to tilt it.
Right. It would probably be a force that you could absorb by changing your body position and the way you're holding it and stuff like that. You'll feel it. I mean, if you ever try to spin a wheel like that and then try to move it, you'll feel it jerking back and resisting all your motions. So, yeah, that would still stand there, but it just couldn't do anything about it. So it would basically have to maintain the angular momentum it had before you rotated it vertically, horizontally, but that would be strictly by the horizontal component
Okay.
of this plus whatever. Yeah.
Yeah, I just wanted to make sure that like it does exist because like the answer does not like if we're asking about a magnitude, wouldn't it be that squared plus the other one squared under the square root?
Yeah, because they are, it's still the same rules of vector algebra, even though, as I told you, these what they call axial vectors are not strictly speaking vectors, so there's sometimes problems with it, but nothing that we would run into.
Okay. Okay, perfect. I have other questions. I'll just wait till other people ask.
Okay, that's cool. Next is Cage. Go for it, Cage, and then Brittany.
How you doing, Professor Younger?
All right, how's it going, bud?
Um, yeah, it's going good. I'm just I don't have any questions. The question that was asked earlier that was pertaining kind of like the redo, it really clarified everything for me.
Oh,
So
good.
I do appreciate that. But what I've been doing is simply just copying, writing down everything by hand. And then prepping for to take a snapshot of it, then to um email it to myself and download it on the Word document,
Yeah,
transferring it to a PDF for you. But
yeah.
yeah,
That
I
should
mean,
work.
if
Let
you
me know if
could,
you have any problems getting the photos. If you do, I mean, there's a way I can do it. I just don't like sending out that stuff because, like I
right,
said in the assignment, I'm asking everybody not to share those. If I go sending
right,
the thing out in its entirety, students would be like, "Oh, well, he sent it to me. Clearly, you don't care." I'm like, "No, I do
yeah,
really care."
right, yeah, exactly. So I was on the same mindset about that.
Good deal.
As well as I was just wondering, I knew I just logged into it again. I'm not sure if you recently changed the due dates for the the redos, but yeah, it seems as if you changed them. So
Yeah, I did
just
move
wanted
them
to
back to
clarify.
the fifth
Okay,
because I had a couple people that had warned me they were going to have to miss, and then also I just had a couple people that just blatantly forgot. So hopefully everybody, you didn't miss any, did you, Cage?
oh no, sir, no, I didn't. I have I have everything in there.
Good deal. Yeah, just remember while you're doing those redos, you're really wanting to try to learn how to do them. But if you're not getting it, then
Right,
what that means is you got to memorize how to do it and then
exactly.
think about it in your spare time because eventually you'll figure out, oh, I bet you they did this because of blah or because of blah. So that process, I don't want to short sell that memorization is always bad. No, memorization is often the lowest level of learning that you can get. And in that sense, you got to do that first before you can make sense of the stuff. And you're in 242. This is a tough class, dude.
Yeah, right. I've definitely noticed that, I have to put a different type of effort, and I've also been watching some of your YouTube videos as well that have, definitely helped me understand some concepts about this upcoming exam. So, it was really helpful as well.
That's cool. Sounds good. We'll stick around and watch as much as you want. And just like I said, feel free to ask me questions. You guys are allowed to help each other on the test redos. And I encourage it because a lot of times a student might explain it to you a way that you understand better than me explaining. So by all means, get help with your fellow students.
Thank you.
You're welcome. Brittany, you have another question other than the one you posted, or do you have some follow up on the one you posted?
Yeah, so I actually just emailed you question 13 and 15 from
Okay.
test two.
All right.
So
Let me pull
I
that up
just
real
sent
quick.
that in an email.
Yep, I see it right now. Now I'm gonna find my glasses. Oh, took them off. Like 40 times a day this happens. So I'm gonna preview. Okay. Battery has an EMF of 43.0 volts and an internal resistance of 8.0 ohms, as shown in the figure. When the terminal voltage VAB is equal to 34 volts, the current through the battery, including its direction, is closest to. Okay, so that's the question. I've got my document up right now, so I'm going to actually show it to you in there. But I'm first going to draw a line to separate it from this part. Okay, so what we have is EMF. Whoa. EMF that's equal to 43.0 volts. We also have a internal resistance that's 8.0 ohms. And what we have is a terminal voltage VAB that's equal to 34.0 volts. And the diagram they have, by the way, is basically you could take a picture of a battery if you wanted. They just drew it as a square. I normally like to draw it as a whole, battery, but that's okay. Uh, what they have here is this. that would be the R, this would be that, and it looks like they're calling this end A and this end B. So what you have to realize is that the voltage VAB is, and this is one of the equations on your equation sheet, it's equal to the electromotive force minus I times R. So what we have to do is use that. So our solution goes like this. We're going to write 34.0 volts is equal to 43.0 volts minus I times 8.0 ohms. So you can see that basically I'll pull the 8.0 ohms times I to the left, and then I'm going to subtract 34 from 43. When I subtract 43 minus 4, I get 39, and then I subtract 30 from it, I get 9. So that's 9.0 volts different over there. Now I divide both sides by 8.0 ohms, and that gives you I is equal to 9/8, and that's of course 1.125 amps. So 1.1 is probably the most appropriate one because you're only supposed to have two sig figs there. Does that make sense to
Okay.
you, Brittany?
Yes, it does. Very simple, very straight to the point. I just didn't know which equation to use because I was actually looking for it and I don't see what you just
Okay,
unless
that means I
yeah.
might not have put it on the equation sheet. That's why what I asked my students to do
Okay.
is if you see one you think you need, let me know.
Right.
I'm okay with putting that one on the equation sheet if it's not on there. So I will definitely look at it and
Yeah.
make sure I do it.
So I'm gonna just go ahead and like write it in on my equation sheet just in case I run into it, if that's okay.
Yeah, that's cool.
Okay.
Did you want
All
me to go
right.
ahead and address the other one, which is question 13?
Yeah, and then the sample question I sent to you yesterday, right? Like
Hmm.
how I did it. I
Right.
get that you don't want me to turn it in that way, which I won't. I will go ahead and put it on a document, but what I am gonna ask is it still okay if I like you seen the methods I use where I was like breaking it down as far as what was given, what was wanted in the equations.
Yeah, that's
Can I
all that's fine. You don't
okay,
have to
so
write it formally like with the word solution. For instance, like Mark in your class, he was going by this guess method, uh,
okay.
and stuff like that. Any method like that's fine. I just need, as long as you show me if you're using
Mm-hmm.
an equation, you show me the equation before you use it, and every
Mm-hmm.
equation you use before you use it, or if you use any principles or laws like Kirchhoff's voltage rule or Kirchhoff's junction rule, just state using this, then that's fair game. And then when you actually use the equation, put the units in with the numbers when you first plug them in, and everything else would be fine long as you circle your final answers.
Okay, cool. And like as far as like, okay, so when I put the screenshots on a Word document, now I don't know if Word will allow me to place the solutions directly under it, being that it's the picture format. So what I was gonna ask, is it okay if I just take pictures of the screenshots that I'm writing the solutions on and then put it on a Word document?
Yeah, that's what I recommended was taking photographs of the
Mhm.
question with the answer, pasting that into the Word document with the margins on narrow, then under
Okay.
the question with the answer choices, then have a photograph of your work and you just paste that in there.
Okay, so okay, because all right. I'm sorry if I'm sounding confused because the way Word works is if you put it as a picture, you're not going to be able to write on it. I don't have like tablets. I know some people got like Apple, Mac, and they can like
Oh,
write on it. I don't have that. I have just a laptop.
yeah,
So
you
when
don't. I don't
I
want that. Yeah,
oh okay,
yeah. I
so
just
what I
expected people to take photographs with their phone and put it in there.
right. So what I am capable of doing is what I have been doing these past few days is actually printing out the pictures and writing on it like you kind of saw me doing before. And
Hmm.
I just want to be sure that it's okay that I can take that work if I were to go ahead and scan it, put it on a Word document, and you'll see my solutions written on the questions, but it won't be like directly I'll circle the answers and everything,
Right.
but it won't be like directly next to it or under it. So I just wasn't sure like if you wanted us to like
Yeah.
actually, you know.
There is a problem. I do need the solution with question one, and I don't want to have to go and look back and forth, flip between one page and another to see the problem
Oh
and
no
the.
no 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 no. Mm-mm.
Okay.
No, like it's gonna be the picture, but I'm also like I'm basically writing on the picture and then I'm gonna scan it to
Right.
document like that.
Gotcha. Yeah, that sounds like you're doing it fine. Don't worry about at all about that.
Okay, all right.
Okay. All
Yep.
right. The other question you sent me a picture of, I'm working out now. This was actually
Mhm.
one I did in class last time. But basically,
Okay.
what you have to do is you have to realize this is charging a capacitor. If you look on the equation sheet I made you, there's a statement where I say Q is equal to Q zero. They actually have
Hmm.
it written this way: Q equals Q zero times 1 minus E to the negative T over RC. I
Yep.
use the idea from C equals Q over V that Q0 is actually going to be equal to C times V. So that's how I got this version.
Okay.
All you have to do with this is first you want to calculate RC because that's the time constant. In fact,
Hmm.
it's called tau. So tau, the time constant, is R times C. And if you multiply those two, you're going to say 50 kilo times 2 micro. That gives you 100. And a kilo times a micro is a milli. So this is
Oh, it's not
100.
showing what you're writing. Oh, I'm sorry.
It's still not showing?
No, it's showing
Okay,
now.
I got you. So that turns out to be 100 milliseconds, which is 0.100 seconds. So all you have to do now to find out the answer to this question is you put in for Q is equal to 0.90, that's 90% as a decimal,
Mhm.
times C times V. And then you set that equal to C times V times 1 minus E to the negative T over 0.10. From that, you can see the CVs cancel out, and then you just solve it like you would normally do. Do you know how to solve that equation, Brittany?
Yes.
Okay,
It's like natural log.
exactly.
Hmm.
So you would end up having, now that you've got rid of the CV, you can get rid of the parentheses. You can bring the e
Hmm.
to the negative t over 0.10. You can bring that to
Hmm.
the left. And then on the right, you're just going to have 0.10 because you subtracted zero point 0.9 from 1. And then what you're going
Hmm.
to do is take the natural log of
Hmm.
both sides.
Both sides. Yeah.
And that gives you negative t over 0.10 is equal to the ln of zero point 0.1, which is negative 2.303. So now you just multiply that by zero point 0.1 or negative zero point 0.1. That'll get rid of the negatives, and that gives you 0.23 seconds. So the answer for
Mhm.
that one should actually be 0. Or excuse me, 0.23 seconds, which you'll see as answer A.
Mhm. Okay.
Okay.
Sounds good. Thanks.
Stick around as long as you want. I'm going to go ahead and ask Mark for his question now. Anybody? Mark?
Hi. I got a question for test two. It's
Okay.
about question 7.
Okay, so it's face-to-face test two for your class. Yes.
Yep. Yep. Yep.
Okay. I'm actually in that class somewhere on my desktop, so let me just find it for a second. That's not it. That's not it. That's not it. That's not it either. I know it's here. Where's it at? Maybe it's here. Yep, I think that's it. Maybe not. Here it is. Okay. So now I'm going to go to modules, and you said face-to-face test for you, right? Number two, Mark.
Yep.
Okay. And what problem was it again?
Number 7.
Okay, number 7. Actually, I should have done this with editing. 1, 2, 3, 4, 5, 6, 7. Electric heater. Is that the one?
Yeah, that sounds about right.
Yeah. So it says an electric heater that draws 13.5 amps. So I equals 13.5 amps of DC current has been left on for 10 minutes. So I'm going to assume that's 2 sig figs. How many electrons have passed? Oops. Passed through the heater during that time. I left off a hump on my during, but that's okay. So what we have here is I, which we know is delta Q over delta T. So delta Q is equal to I times delta T, which would be equal to 13.5. Now, an amp is a coulomb per second, so I'm going to write it as a coulomb per second this time for obvious reasons. And then I'm going to say 10.0 minutes times 1 minute in the bottom is equal to 60 seconds on the top. And when I do all this math, I get 13.5 times 10 times 60, and that gives me 8,100 coulombs with 2 extra digits. Okay. Now, if I want the number of electrons, what I want to do is take the delta Q and divide it by the charge per electron, which is 1.6. Your book is telling you, or this test is telling you to only use 1.60 times 10 to the negative 19th, and that's coulombs per electron. So if you take 8,100 coulombs and divide it by 1.60 times 10 to the negative 19th coulombs per electron, you get 1.6 10 to the negative 19th. You get 5.06 times 10 to the 22nd E minuses. So it should be about 5.1 times 10 to the 11th. Or excuse me, 10 to the 22. I don't know why I said 11. And that is listed as the correct answer.
Okay, okay. I just thought that the delta Q was the electron that was given, so I guess that's where I got messed up.
Gotcha. That makes sense.
Thank you,
Anything
Professor.
else, Mark? Do you have another question? I've been giving everybody, like, everybody's been taking 2 questions. So if you have another, you can go ahead and do another.
No, I think that's it for me. I'm gonna
Okay,
do the
cool.
practice exam later and ask you tomorrow. Is that okay?
Yeah, that's no problem. Remember, I got office hours tomorrow and Sunday, so you're good.
All right.
All
Have a good day,
right.
Professor. I'm
You
just gonna
too,
listen.
Mark. All right. Hadi, do you have another?
Yes, I do. The last question concerning the center mass
Uh-huh.
on the last face-to-face test, could you pull it up? Because like if I have to open lockdown browser, it'll shut down everything.
Right, yeah.
So
So you
yeah,
want your second face-to-face test for your class?
yes, sir, please.
Okay. I will pull that open. I'm going to my modules. Now I'm going to face-to-face tests. Now I'm going to face-to-face 3, you say?
Yes, sir.
Okay. And then what question number are you talking about?
Last one, center mass. I
Okay.
remember if
Gotcha.
I asked you about it in class. Um,
Three masses are located in the XY plane.
yes.
Okay, cool. All right, so let me write down. I'm going to read this to everybody, and then I'm going to write down the information why I'm reading it. So let me do that real quick. It says that three masses are located in the XY plane as follows. A 6 kilogram mass is located at the origin. So M1, I'll say, is equal to 6.0 kilograms. It looks like your book is trying, or this question is trying to suggest one sig fig, but I'm going to go at least with two. And that's at the origin 0, 0. And then we have a 4 kilogram mass, and I'm going to call that M2. 4.0 kilogram, and that one's at the point 3 meters, comma 0. So that's x equals 3 meters, y equals 0. And the third mass, M3, is equal to 2.0 kilograms. And that's located at 0 meters, comma 3 meters. I don't know why sometimes it wrote it. Oh, no, it actually wrote a meter. It was me that did that. So all the zeros have meters with it as well. I just didn't write them initially. And what it's asking is what's the center of mass of the system? So when you're doing discrete like this, does everybody understand the question now? Or I know Hadi does, but if anybody else has any questions, make sure you ask me. So the x center of mass
I don't
is
think there is anyone from 241 except me here.
what's that, Hadi? Oh
You
yeah,
are.
yeah, I think you are right. You're the only one from 241. Oh no, Brittany's here. That's right. No, no, that's Brittany's here, not Honesty. I was thinking Honesty, not Brittany. She was here
Yeah.
earlier. So the x center of mass is supposed to be m1x1 plus m2x2 plus dot 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 plus on up to mnxn, and then I divide it by m1 plus m2 plus dot 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 plus mn. So in this case, we're going to get 6.0. I'm going to leave the units off just for saving time. The x component, of course, or the x position, of course, is 0 for that one. Then we have 4.0. The x position of that one is 3.0, which I'm going to treat as two sig figs. And then the 2 kilogram mass is also at x equals 0. And then I have to divide all this by 6.0 plus 4.0 plus 2.0, which the top is obviously going to be kilogram meters and the bottom's going to be kilograms. So you're just going to get meters out. But you can see that the bottom 6 plus 4 is 10 plus 2 is 12. So really we just got 12 divided by 12 because the 4 times 3 is the only thing that gets you anything. So you get 1.0 meters is the x center of mass. And then the y center of mass is the same type of formula, so I'm just going to write it down. 6.0, the y position of that is 0, plus 4.0, the y position of that is also 0, plus 2.0, and the y position of that is 3.0 meters. I don't know why all of a sudden I just put a unit in there. But again, this is going to be divided by 12.0 kilograms.
Right.
So I've got 2 times 3 is 6, divided by 12 is 1/2. So this one's going to be 0.50 meters equals y center of mass. So
So
that should be the right answer.
do we still, I believe it is.
It is, yes. I just checked it.
Um, so do we still add the masses even if they're not on the axis?
Yeah, absolutely. Yeah, you have to add,
Okay.
you have to take all the masses, and then, like I said, it's just the y coordinate when you're doing the y center of mass, and it's just the x coordinate when you're doing the x center of mass.
Yeah, because I did it in the test and I got like that it was leaning more towards the lighter object, and I was like, this doesn't make any sense. So I did it like sort of intuitively and I got a similar result, but um okay, that must have been my mistake.
Gotcha.
I got it. And so we're only adding, and the distance would be 0 for the object on the y-axis, the one above the reference point.
Yeah.
Okay, we wouldn't. Okay, so it's like the x position. Fair enough.
Yep. Yeah,
All
it's
right,
not.
thank you.
It's a little confusing when you look at the formulas. Sometimes they look a lot worse than they are, but when you actually see it done, you're like, "Oh, okay, well, that's pretty straightforward."
Just plug and chug.
Uh, I know Cage said he didn't have any more questions, and I think Brittany was in the same place. But if y'all do, by all means, ask me. But right now, I'm asking Sydney because she just came back. Brittany, did Cage or Brittany, did y'all have one before I go on to Sydney?
I did, but I
Okay.
just found the answer to it. So the question 15 that you just did for me,
Uh-huh.
you never explained why it was in the direction from B to A, but then when I looked at the graph, it's very faint, but you could see the arrow leaving B
Right.
go in that direction. So I think that's why I got that question wrong on the test because I didn't see
You didn't
that
see that
arrow.
arrow? Yeah.
Yeah.
Feel free. You can sort of zoom in on areas. I think you're able to, even in the lockdown browser. So feel free to do that when you're taking the test, uh,
Okay. Well,
or
now I know to
use the
keep an eye
magnifier
out for that.
glass. Okay, that's cool.
Thank you.
You're welcome.
One more thing,
Yeah, go ahead, Hadi.
not a question, just letting you know, the equation sheet on the canvas is still wrong.
Is it still don't
Um,
have that G in the bottom of it?
the G for one, and secondly, the summation of torques on the bottom left corner of the first sheet.
Okay.
Uh, it says sigma torques, or the sum of all torques equals mass times the angular acceleration. I think we talked about it in class, should be the inertia or the
Right.
the momentum, the I thing,
Hmm.
times angular momentum. And on the at the end of it, it says m times the second derivative of the position over time. It should be also
Gotcha. I
moment
will check
inertia.
that as well. I just wrote a note. I know that we have the G thing. I did fix that, but it's evidently there's several copies floating around. And you said at the bottom left there was a summation of the torques question
Yep,
that was problematic.
yep,
Oh yeah, I had summation of torques equals M times A alpha instead of I times alpha.
right.
Yep, I see it now. Thank you. Appreciate that.
No problem.
Sydney, did you have a question, or were you just bumped out earlier by accident, or what? And I'll turn on my chat in case you're unable to talk. I
No
probably help.
question for me.
Okay, thanks, Cage. Got that, got that, got that. Oh, okay, thank you. I'll check your my email real quick, Sydney. Oops, I checked
Have
the wrong thing.
I don't know if I didn't hear, but did you say anything about whether it's going to be work shown or multiple choice, or are we just going to see in the test?
You probably won't know till the test day
Okay,
because I really haven't decided yet. I keep toying with it. I've got like four different versions I'm looking at.
work
There's
shown. And for chapter 11 and 12, the chapters we didn't cover in class only on Zoom, are we going to have questions of them on the test, or is it just so y'all know type of situation?
Sorry, I was thinking about something, so I couldn't process what you said. Sort of like I didn't hear it, but could you say that again for me, Hadi? Sorry.
I got you. For the last, for chapter 13, 14, the ones we covered on the Zoom meeting Wednesday, I believe, are
Hmm.
we gonna have questions of that on the test, or is it just so y'all know type of situation?
No, you could have stuff from chapters 11, 14, and 15, but they're exactly faithfully represented in the practice exam I made you. So I made sure I
Okay,
didn't include any extraneous stuff in there.
okay.
In fact, the vast majority of questions from chapters 11, 14, and 15 are actually conceptual questions, and there's really a very limited number of computational questions in there.
I got you. Thank you.
You're welcome. All right, Sydney, I'm looking right at the question that you sent me. And yeah, they only gave you the Q as microcoulombs. What is the energy density of the electric field between the two plates? Okay, so that's actually completely doable. Let me show you what that entails. So what we have here is A is equal to 0.25 square meters, and we've got Q is equal to 75 microcoulombs. And what we know for a parallel plate capacitor is that the electric field, and I'll say EPP for parallel plate capacitor, and I'm talking specifically when they have equal but opposite charges, that electric field is just sigma over epsilon naught. But sigma is equal to Q divided by A. So in this case, we're going to get Q over epsilon 0 times A is what the electric field is. Then you rightly knew that the energy density, which is the lowercase u, is equal to 1/2 epsilon 0 E squared. So if I plug that in, I'm going to get Q over epsilon 0 A. All that's going to be squared. You can see that, in fact, it's going to give me Q squared over 2 epsilon naught A squared. That should be your ultimate result. Let me calculate what that is. You got to remember to convert the micro to actually coulombs. So I'm going to take 75 times 10 to the negative 6. I'm going to square that. And that gives me 5.62 times 10 to the negative 1, 2, 3, 4, 5, 6, 7, 8, 9, roughly. So now we're going to divide that by 2 times 8.85 times 10 to the negative 12th, which is epsilon 0, times 0.25 squared. That's already in square meters, so we're golden on that one. And that gives me 5,084.7 joules per cubic meter. And we were only given 2 sig figs, and this was all multiplication, so it should be about 5.1 times 10 to the third joules per square meter or cubic meter, excuse me. And let me check that answer real quick for you. You said 3.4. They're saying the 5.1. And you said you got 5.1 as well, didn't you, earlier, Sydney? I'm looking right now. I'm actually looking back at what you, yeah, correct. So yeah, that's exactly right. 5.1 times 10 to the uh, third. Whoa. Yours has 10 to the 15. Now I'm a little confused. Oh, there it is. Oh, grad. Oh, Jesus. But it had 10 to the 15th. Okay, yeah, so something's jacked up with that. It's not supposed to be 10 to the 15th. E squared, 1/2 epsilon 0, E squared. That's exactly right. So yeah, it's off by a factor of 10 to the 12th or something. Yeah, was this, Sydney, if you can type this, was this on your first face-to-face test or your second one or your third one or what? Do you recall? Because there appears to be no right answer on this just because of the exponents. It was on multiple practice tests. Thank you. I can fix that. I can find exactly which one it is, and I can fix it. I just got to track it down because it'll be in multiple banks, which is a little bit more of a pain, but we can do it. So yes, 5.1 times 10 to the third is the right answer. 5.1 times 10 to the 15th is definitely not the right answer. I don't know how this got screwed up unless the problem's been altered some way. Like originally they had 0.25 cubic centimeter or square centimeters for the area or something. That would account for 10 to the fourth squared. So it'd be like 10 to the eighth difference, but still that still leaves you 10 to the 12th, not 10 to the 15th. So yeah, I don't know why that one's jacked up, but I definitely got to fix it, and it will not appear on the final unless it is fixed. So if you get something like that on the final, just work it the way you did. Everything you did is right. Whatever these crazy answers are is crazy and ignored. Anyone else have a question? Yeah, that's definitely going to change. I'll definitely fix your grade on that. In fact, when I fix the question, it's probably, if I fix it on the test, it automatically fixes it itself. So if you don't see it's fixed, make sure you let me know before I submit my grades. But I'm sure, like I said, I've got a note written here in red, so I should catch that. I'm working on putting in lab grades tonight, and by Sunday evening or early Monday morning, I'll have omitted the lowest scores within your homework and conceptual homework stuff, so that basically your homework score won't be dragged down by all the extra credits getting zeros for not being turned in. I'll have counted those up, and your total course grade will change a lot by then. But I want to make sure everybody knows what that is before they take their final. So that's why I have it done definitely by Monday morning, if not, Sunday afternoon. Anybody else have any questions? Looks like there's only
I
three of us left.
Yes, I did.
Go ahead.
Last question for me is question 14 on test two.
Okay. Question on test two. And you said it's question 15?
14.
14? Okay, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14. That one with all the resistors.
Yes.
A number of resistors are connected across a point. Yeah, we actually did this in one of the meetings we had too, so it's good that you asked it because everybody else had the same problems. Let me show you. I'm going to first copy it down and then I'll solve it. So I got to get the information first, which is basically we have a wire, a resistor, another wire, a resistor, uh, the same resistor right here. And then from there, I go to two resistors like this. And I don't know why this thing keeps making it. Actually, I do. I just fixed it. I know these are horrible looking resistors. I apologize, but I'm just trying to get it done. And then there's one more. So this looks like it. This is 6 ohms. This is 6 ohms. This is 6 ohms. These are all 2 ohms.
The last one was 4 at the
Oh,
very
thank you.
end.
Yeah, I thank you for catching that because that would have definitely screwed everything up. Yeah, but these other ones are too, so we got that. So when you're looking at one of these, what it's asking for is the equivalent resistance between points A and B, and this is point A, say, and this is point B, and they want to know R equivalent equals question mark. Okay, so solution, what we have to do is use our two formulas for equivalent resistance. So equivalent resistance in series is R1 plus R2 plus dot dot dot, and 1 over R equivalent for parallel is 1 over R1 plus 1 over R2 plus dot dot dot. So that's what we're going to use. And the way you do this is you normally go ahead and attack any two or more resistors that you can based on the formula. So if I have two or more resistors that are in series, I should go ahead and replace them with the equivalent. And if I have two or more that are purely in parallel, I should go ahead and replace that. So what I'm going to do from the very beginning is I know the equivalent of these two is just 1 4 ohm resistor. and the equivalent of, well, these are 2 as well. I forgot to write those. So this would be 4. This would be 4. And then 4 plus 4 plus 4, that means this whole end would become, in fact, 12. So I'm going to go over here and just write this and say this is 12 ohms. This
So why
one's
does that, so why would it become that at the end, even though it's like, because I think my problem is I wasn't sure how to break it up to really get the proper number and resistance.
right. Yeah, so the thing is you can only take 2 or more resistors at a time, and they have to
Okay.
be exactly parallel or exactly in series. So right now I could have taken all 5 of those resistors on that end. There's no alternative. If you go through the first 2 ohm resistor, you have to go through all of them. So that's the hallmark of series, and there's 5 of them. So I could just go 2 plus 2 is 4, plus 4 is 8, plus 2 is 10, plus 2 again is 12. That's how I got that. And then
Mhm.
now I can go back and do all this as well. And the only difference, of course, is now that I got one of those areas simplified. But you can see right now that the 6 and the 12, you see that they're in parallel.
Oh, okay. I see what you're saying.
Yeah, so those 2 are in parallel because if I had another resistor, for instance, below the 6 or above the 6 or below the 12 or above the 12, then whatever would be above or below the 12 would be in series with it, and whatever would be above or below the 6 would be in series with it. So we'd want to do those. But right now, I don't have anything like that. I just have 2 that are in parallel. So this says 1 over R equivalent would be 1 over 6 plus 1 over 12. And I'm going to, of course, multiply by 2 over 2 to get a common denominator. And then that, of course, gives me 3 over 12, which means R equivalent is just 4 ohms. So now I can say that basically I have this resistor, which is 4 ohms, in series with this resistor, which is 4 ohms, and this resistor, which is 4 ohms, and this resistor, which is 6 ohms, and then 2, and then 2. So now I've got a 4, and a 4 that are all in series. Notice the 6 can't be counted in series there on that end, but the 4 on the ends, the 3 fours can be. So they're 4 plus 4 plus 4, which is 12. So you see what's going to happen. I'm going to get another, oh, excuse me. I'm going to get another one just like the last one. So now it's going to be 2 ohms, 2 ohms, 6 ohms, 12 ohms. We already figured out what 6 and 12 gives us. That gives us 4. So now I'm going to say 2 ohms, 4 ohms, 2 ohms like that. And then, of course, you know that's 4 plus 4 is 8. So the equivalent is basically just a single resistor with an 8 ohm resistance.
Okay, that makes so much better sense than all of like the math I was seeing people do. It actually helps to draw it out like this a
Yeah,
lot.
that's the way I try to do it in class. If I have enough room, I try to, piece by piece, replace it with a new piece of circuit, and then work out the next one, and then replace that with a new piece of circuit. That helps a little bit.
Okay. Yeah, thank you. That definitely helped me a whole lot because I think it's not that I couldn't understand the math. I just wasn't sure how did they arrive to get 8 with all that they were doing. So, thanks.
Gotcha. Okay, no problem. Glad that helped. Anybody else have anything? All right. Well, it looks like no one else has any questions, so I guess I'll just go ahead and say bye. It's about time. My wife just pulled up, in fact, so might get to eat supper now. Yay! I'm
Good night.
eating at Blue Hair 30. You have another one, Brittany? You think of one? Oh, she did go by. How about Cage or Sydney? Y'all have any more questions?
See Professor Younger. Be safe.
All right. Thanks, bud. Appreciate it. Thanks for showing up.
Thank you.
Feel free to text me if y'all have any problems. You still there, Sydney? All right, she's gone.